Good morning, students. Today, as I will going to discuss you the iteration loops with a prime number program, different type of prime number program that today I am going to discuss with you. In those different pattern of prime number program, we can see it that how the loop we can implement and how we can work with that particular loop, isn't it? Those the different type of loops or different structures of loop that we have, those the different pattern of loop that we are constructing. So each of this particular pattern of loop, each of this particular structure of loop, we are having it and we are maintaining it. So as we are maintaining the pattern, as we are seeing the pattern, let us see what the program based on the basically on the number system that we have with an iterations. Now see the first program. In this particular program what we have, as I said, that prime number program with a loop. So in this particular prime number program with a loop, that we see it, we can find it that for n in range 1 comma 101. Now why 1 comma 101 that we have taken the range value? Because I have to run it up to 100. So as I need to run it at up to 100, that this the particular range that we are constructing, this the particular structures that we are constructing in this particular pattern or in this particular structure, we can find it and we can see it that how the thing will going to construct. Okay, so as we find it that how we are constructing it and how we are making this particular structure. That means as we know it, as we know the particular format, it has been discussed with you earlier also, that when you discuss the range, when we see the range, this particular range, when we have this particular range that we are having, and we that we are finding it. So these the particular structures that we can work with, we can find with that those the structure what we have, those the pattern that we are using, and we are making those the pattern. So as we are making the pattern, that means I want to start from 1 and I want to do up to 100, because range will run up to that figure, and before of that it will going to stop the work. So as we find it that this is going to have, then what we find, that count equals to 0. The value of count is equals to 0. Why count is equals to 0? Because we have taken one counter here. Okay, one counter value has been taken here. Now what we find it, that for I in range 2 comma n minus 1, that means it will start from 2, and what will be the n minus 1, so up to that the n minus 1 the thing will going to run. Okay, so if n modulus I equals to 0, if you find the n modulus I is equals to 0, this particular thing is that means n modulus I means what, we can see it that there is a particular pattern, there is a particular structures that we are constructing, that we are making it, and when we are making those structures, when we are making this particular pattern, when we are having this particular pattern, what we say it, that this particular pattern of the structures, this particular pattern of the work will going to implement and will going to make in the way or in a pattern that we find it that we are having the particular structures, and we are working on this particular structures. Okay, so what is that, that I for I in range is what, 2. Start the value of I from 2, and as the value of I is from 2, from there we can see it, from there we can find it that those the particular pattern, those the particular structures that we have, that we find it that here it will going to have this particular implementation. Next, another loop I have started here. What is that particular loop? What is that loop that we find that in this particular loop that we have it, and we can see it that there the loop what we are having, or what we are making, we can find that if loop we have constructed here. Okay, in this particular if loop, in this particular if pattern of the structures of the loop that we are constructing, and that we are making it here. So if pattern of loop, what it will going to check? It will going to check whether the value of n divided by I equals to 0 or not. If it is equals to 0, then we can find it, the work will be done. So count equals to count plus 1. So when count equals to count plus 1, in this particular count that we can see here, so this is the particular count that we are having, and we are making it, and we are working on this particular pattern of the things that we are constructing here, and we are making it here, isn't it? So this is how we can find it, this is how we can see it, that when we are constructing this, then what we have here, count equals to count plus 1. So as count equals to count plus 1, that means we will going to construct this particular structures, and when we are constructing this structure, you see here, if count equals to 0 and n not equals to 1, if this is then we will going to have here in this particular pattern, so print n. So what we can find it, that we have this particular pattern that we are going to have, and we will going to work on it. Okay, we will going to work on it. So this is how we can see, this is how we can find it, that how we can have the particular pattern to be implemented. So let us see the output of it. So see here in this particular output, you see that we have taken started from 2, as we have started from 2, that means see up to before of 100 the prime number series are been implemented here. Okay, so this is how we can find it, this is how we can see it, that this the pattern of the structures that we are constructing, we are making it, this is the output, we can get it from here, and we can implement it from here. Now let us see the next program that we have with a prime number. So now see the another program of a prime number from 1 to 100, we using a while loop. That means here we have used the while loop, and inside the while loop we have implemented the if, isn't it? So in the while loop, when we have implemented the if, we find it that we will going to have this particular pattern, and we will going to have this particular structure. So as we are having those pattern, as we are having those structures, so we can find it that we are having this particular pattern, and we are having those particular structures. So as we are having those pattern, as we are having those structures, so each of this particular pattern, each of this particular structures that we do have, how we can implement it, how we can make this particular thing to be implementable. Okay, so this is the particular thing that we can find it. See, n equals to 1. Okay, now here while loop, previously you have seen here for loop, and there is one range has been given. Here I haven't given any range. So when I haven't given any range, that means it will run up to the figure. I will make it to run up to the figure and extract the value up to that much. So how it can be done? So while bracket open n less than equals to 100, when the value of n is less than equals to 100, then what we can find it, that we will going to have a structure. Condition is true, yes. If the condition is true, then it will go inside the loop. So what it will going to do, say count equals to 0, the value of count has been given equals to 0, and next what you can find it, I equals to 2, the value of I is given, that value of I will be equals to 2. Okay, now you can see here that while I less than n, while the value of I is less than n, and that particular pattern or that particular type, that we can find it, that when the value of I is less than 10, there what we can see n, that means n is what, n is the value that we have taken, one. So as we have taken it 1, that we can find that if n divided by modulus I equals to 0, modulus means a remainder. If we get a remainder is 0, then what, count equals to count plus 1. Okay, count equals to count plus 1 and break. So I equals to I plus 1. So I equals to I plus 1. So if count equals to 0 and n not equals to 1, then what we can find it, that print n. So those the thing that we will going to see, those the thing that we will going to find it, that we will going to have this particular pattern, and we will going to have this particular structure. Okay, so print n, we need to print out the value of n. So n equals to n plus 1. So this is what we can say, this is what we can find it, that how we do construct, how we do make it, and how we can implement it. So those the implementation that we find it, those the implementation that we are giving and we are executing it here in this particular implementation. What we have here first the while loop. Okay, so while loop is this, we are checking it while the value of n is less than equals to 100. So when the value of n is less than equals to 100, those the value of n when it is less than equals to 100, what we find it, count equals to 0. Okay, this the particular pattern, this the particular structure that we are making the pattern, we are making the structures. So when we are making this particular pattern, and when we are making this particular structure, we can find it that we will going to have this pattern, and we will going to have this particular structures to be implemented. Okay, so as we are implementing it, see here, then the next checking has been done. So this while is inside the first while. Okay, this particular while is inside the first while. So while I is less than n, so value of n should be greater than I. What it has done, that if n modulus I equals to 0, if it is so, then that means if it doesn't get the remainder 0, then it will come count equals to count plus 1. That means we need to increase the value of count, and then break, then I equals to what, I plus 1. So if count equals to 0 and n not equals to 1, then what we can see it, that print the value of this n. What will be the value of n? That is to be printed. Okay, so when we print the value of n, then n equals to n plus 1. Okay, so in n equals to n plus 1, this is the thing, this is the part that we are constructing, and we are making it, we are making those pattern of structures, and we are working on this particular pattern of structure. On this particular pattern of structures, we can find it that how we will going to have those structures, and how we can make those particular pattern of structures to be implemented and to be worked with. So this is how that we are constructing it, and we are making it in this particular pattern of work. So let us see what is the output that we will going to get it from here. Now see the output. In this also we have taken out the output. See, from 2 we have started here, and what we have given, that 100 to that is greater than equals to 100. That means up to 100 it will going to go, and it will going to fetch the value from there. So this is how we can say, this is how we can find it, that when we are constructing the data, when we find that we have constructed the data, those the data that we are implemented it here, we can implement it in this particular way. This is also one pattern of loop, that only using the while loop, and if that we find it that we have the construction of the structures, and we can work with this particular structure. Okay, so this is how that we can do it, and this is how that we can find it, the implementation can be done. Now let us see another program of the same program with using the different loop. So see here, this is another program. In this particular program, what you have, that here I have taken the two things. First the maximum value, then the minimum value. Minimum value and maximum value, that means from where you want to start and where you want to end. Okay, so I have given one certain range there. So what we say, that for num in range, m is the minimum value, and n plus 1. Why n plus 1? Because when we have used the range function, if you give n, that means it will run up to n, but it will extract the value before of the n. So that we don't want. We want to extract the value up to n only, so not before of the n. So that means we have given here n plus 1. After we give here n plus 1, we find here that count equals to 0. So value of count will be equals to 0. As the value of count is equals to 0, then for I in range is what? 2. So to start with 2 and num minus 1, what will be the value of num? That the value of num minus 1 it will going to do. So now you see here that what we have done, if num modulus I equals to 0, if it is equals to 0, then count equals to count plus 1. So this the value of count we have done, and break, isn't it? So if count equals to 0 and num not equals to 1, then we can find it that we will going to have this particular structures, and we will going to print the value of num. Okay, so this is what we see it, that different types of implementations that we have given. So what are the loop we have implemented? For loop, then two for loop is there, one for loop, under this for we have given another for loop, and when we find that in this particular for so there we find it that when we are implementing it, and when we are working on it, there we are having what? If n num modulus I equals to 0, if it is so, then we can find it that count equals to count plus 1, isn't it? Count equals to count plus 1, then we will going to give a break there. So this is the thing that we have implemented it here, and we can work on this particular structure. So these the particular structures that we find, this the particular pattern that we find, that we are implementing it and we are using it. So if what we say, that if count equals to 0 and num not equals to 1, if it is so, then print num, then it will going to print the value of num, and we will going to work on this particular area. Okay, we will going to find it that when we are working it, when we are finding those pattern that we are working on this particular area. Now let us see what the output that we will going to get it from here. Now see here, as I have run the program, you can find here that it has asked to give the values. Let us give the minimum value from where do we want to start. Suppose I want to start from 5. Okay, and then enter the maximum value. Suppose maximum value I am giving here 85. Okay, so in between that, what are the prime numbers are there? See, those are the prime numbers in between our value that has given. What is the 5 and 85? Between 5 and 85, we have those particular values that are known as a prime number, and based on those particular values, what we can see, we have the executions of the program that is been implemented, that is been worked with. When we find that we are working on these structures, we are making those particular pattern of structures, this way we can do it and we can implement it. So thank you students, today I am ending my today's session here. Thank you all.